Welcome to this month's presentation for the Denver chapter of the Colorado Renewable Energy Society. As you see, today's date is March 21st. Our guest speaker is Mark Attard from Old Town Design. His title is A Practical Guide to Going Passive. He'll be speaking just momentarily after a few announcements for our organization. The Colorado Renewable Energy Society is we foster and encourage a carbon neutral Colorado powered by 100% renewable energy. We want to transition the Colorado economy to a new energy economy that is 100% renewable through education, engagement, and creating networking opportunities across all different communities. I want to stress this latter point. We provide education and good information to help support this transition, but that cannot be done. We cannot get this, we cannot transition our economy into a new energy economy without meeting one another, without creating community, without creating opportunities for entrepreneurs to meet, exchange ideas, for employers to find employees, employees to find employers, consultants to make connections with clients. We have, oftentimes we have academics and researchers and engineers in our audience. So we'd like to make a case that we need to meet in person and make these connections so we can move things along in our community. Our values are, we value renewables, emerging technologies, efficiency, diversity, and inclusion in the community. CRES is a statewide, nonpartisan, nonprofit 501c3 membership organization. It's important to acknowledge who we can give thanks to for helping support this organization. We are, of course, supported by membership fees, but as well as with these corporate sponsors and these organizations. Moss Adams is an accounting firm, Kelly Government Solutions, Sinton Instruments, Solaris Energy, just to name a few, the Poudre Valley Electric, and we've got Bright Sense, Colorado Green Building Guild, the Solar or Sandbox Solar, COSA, which is the Colorado Solar and Storage Association. It's nice to acknowledge some of these folks that make this organization possible. Upcoming events on Thursday, April 18th, the Denver chapter of CRES, right here at the Alliance Center, downtown Denver, is hosting Dr. R. Paul Williamson of STE Holdings. His topic is sustainable change, or his title is Sustainable Change is the Key to Our Future. He'll be talking about a business model, a plan that can make hydrogen powered trains economically feasible and sustainable within our particular community, which is a timely topic given Jared Polis's, our governor's, proposal to build a rail system from Fort Collins all the way down to Pueblo. So this could be the time for this hydrogen solution. About 10 days later or so, next week or so, Jefferson County CRES on Thursday, March 28th is hosting a hybrid event. The title of the topic is the Energy Transition and Community. The Energy Transition and Community Solar's Role in Tribal Energy Sovereignty. The speaker will be Selena Derek Schweiler, who is an Alaskan native. And we encourage you to join our group. So without further ado, we are here to see Mark Attard. I will release the screen here and turn this presentation over to Mark. Just one moment.
Okay. First of all, I want to thank CRES for inviting us. I'm actually here kind of more of an official capacity as a representative of the Rocky Mountain Passive House group, which I am the outside coordinator. There's a couple of people that, well, a bunch of volunteers that help run the organization, but Tyler Whaley, an architect in Lafayette, and myself work on coordinating different activities, which is primarily a monthly meeting for that chapter. That chapter sits underneath the Passive House Network, which is a national network of, I think, roughly about 10 or 12 different chapters across the country, which is also part of the International Passive House Alliance or Association. Besides that, my day job, I am Business Development Director of Old Town Design Build in Fort Collins. We are a Passive House Forward general contracting and design firm. We are excited to be working on several passive houses this coming year. My credentials in terms of passive house and just in terms of general overall high performance building go back many years. I took one of the first passive house courses here in Colorado before there was really any designations of certified tradesperson or certified designer. Been involved with passive house since that time, and recently I took training through EMU and became a certified passive house tradesperson, and I'm currently as well training to be a certified passive house consultant. I've been a passive house tradesperson for a while. I've been involved in several passive house projects on a number of different levels. And today, really, what I really want to talk about is I want to talk about just what passive house is in a quick overview. But I'm assuming that a lot of you understand some of the basics of passive house, and I want to get into a more practical guide of how we want to put together a passive house project to be successful, as opposed to getting into the nitty-gritty of the building science per se. So just a quick overview. What is a passive house? A lot of people don't necessarily know what a passive house is. They don't necessarily, they have some ideas. Back in the day, there was this concept of passive solar house, and a passive house is not a passive solar house. A passive house really is a number of different things. And one of the first things is that it's just generally a concept. So what we see up there is we see it is a building in which thermal comfort can be achieved solely by post heating or post cooling the fresh air mass, which is required for sufficient indoor air quality. So that's the general concept of a passive house. But passive house is also generally a building standard as well. That is truly energy efficient, comfortable, affordable, and ecological. One of the other aspects of passive house is that it's a methodology. So the methodology of passive house seeks to reduce cooling, dehumidification, and heating loads by focusing on durable passive house building components, thermal bridge-free insulation, continuous air tightness, high performance windows and doors with solar protection, and balanced fresh air with energy recovery. And finally, what we're going to be talking about today is that passive house is a building. So it's kind of mentioned in the previous slide, there's 5 basic concepts that make up a passive house. First of all, there's climate specific insulation levels. So one of the things about passive house and what the passive house acknowledges is that there's different climate zones that we build in throughout the world. It is necessary for us to look at the building within the location that it's going to exist and with the orientation that it's going to have in relationship to things like shading, the sun, etc. All those things are kind of accumulated in the model that spits out and tells us what the appropriate insulation levels are for us to meet the basic criteria of passive house. For those of you who don't know, those basic criteria have to do with energy loads and have to do with air tightness. And we'll go over a little bit of what those requirements are and a couple of other slides. So to achieve those requirements of passive house, we also need thermal bridge-free construction, which simply put means we need to have no bypass of energy from inside the building to outside or from outside to inside. We need air tightness, and we need air tightness at a very high level. In Passive House, we are at an airtight level of 0.6 ACH 50, where our codes today are a 3 ACH 50, and although admittedly they are moving those codes down into tighter air tightnesses as we move forward in the next few years. We also need high performance windows. Now, does a high performance window necessarily mean a triple pane window? No, it depends on the location in which we're building the house. In some locations, a double pane window may be fine. Ideally, what we want to do with our windows is we want them to meet what we call a hygiene criteria and a comfort criteria. The hygiene criteria is that it's not going to mold or mildew due to condensation being developed on the inside of the building. And comfort criteria is that there's very little, there's minimal delta between the surface temperature of the window and the indoor air temperature, so that you can sit next to that window and feel comfortable. Then fifth, we need high efficiency heat recovery ventilation. So essentially what that is, and I'll kind of steal some stuff from my friend Enrico at EMU Building Science. The ERV or the HRV are the lungs of the house. So they're going to filter the air that's coming into the house at a high rate, but then they're going to exchange the cold air that's coming into the house with the warm air stale warm air that's exiting the house, so that we bring in fresh warm air into the house at a continuous rate. So just a real quick overview of what we might expect here in our climate zone. So typically here on the Front Range, we are going to be in a climate zone 5, 5A, maybe 5B, more than likely. And it's important to emphasize that this is just an example. Every house is going to be different, and the house next door to you may be different than the house that you're building, just in terms of orientation, and the design of the house may affect these different factors. But typically, we're going to expect that we're going to have high levels of insulation under the slab, whether you're building with a basement or, let's say, on your foundation in general. So roughly about an R30 under the slab, I found relatively consistent on some of the projects that I've worked with around here, but it can be lower, it can be higher. Again, this all comes back to the modeling and what that model's telling us. The same thing for the walls, R35. That's a good general rule of thumb if we're just trying to have a quick overview and preview of what a house might look like in our climate zone that's a passive house. And then the R value in the roof is going to be 65 and probably higher. We are going to have on the outside of the building, which is a requirement by code anyway, a WRB or weather resistant barrier. So we're just going to use a different type of material that also is that's going to allow for more active drying as opposed to bulk water shedding. It's going to have a combination of purposes. We're also likely to have an airtight membrane on the interior of the house that allows us to maintain the airtightness levels that are required in a passive house. And of course, if we're going to have these high performance windows, and in this climate zone, those are going to be triple pane, and that's probably not going to. In fact, I'm not going to say probably, that is just going to be the standard. It's going to be triple pane for us in our climate zone. Then we do have our ERV in there, and the reason why we have an ERV is for a couple of reasons. It's to bring that fresh air in and have that indoor air quality, but it's also to help us manage the moisture. We've made the house very, very tight. There is going to be moisture buildup in that house. We want to make sure that we manage that at appropriate levels. So again, I have a note in there that all of these values are going to be dependent on what the passive house planning package tells us. That is the energy, that is the model, which is basically a big spreadsheet that your passive house consultant is going to input all the data for your house that's going to tell us whether we meet the standard. And as we make changes to the design of a house, as we go down our path towards building, they're going to make those adjustments to make sure that we're still on track. So how do we achieve a passive house in a pretty practical way? I think the first thing to understand that about passive house, that it's product agnostic and it's really a design-based standard, meaning that us as a builder, we have to build exactly what is on that plan. And that plan has to meet up and coordinate with the passive house planning package. So before we do anything else, we are making sure that we have a plan that meets the standards. So it really is it's a preliminary approval, if you will, that the design is going to meet the standard. So again, it's passive house is a product agnostic, design-based standard that opens the door to all the possibilities of what we want to see in today's building. What I mean by that is passive house can open the door to all the things we've been talking about nationally, internationally. All electric homes, net zero ready, carbon free or carbon neutral homes. Passive house can be the gateway to all of those things. Primarily because everything is based in science, we can understand exactly how that building is going to perform before we even build it. And then we can also, at that point, we can decide what other things we want to add on to that, depending on our particular predilections for our house. So if we are looking for carbon neutrality, that's going to affect things like what we're going to choose in terms of product. Thus, the reason why passive house is product agnostic. You could use a lot of carbon heavy products in a passive house and still meet that standard. It's not telling you you can't do that. But really, if that is somebody's goal, this becomes the path. Can become the pathway to doing that. And in fact, in recent years, Passive House has introduced some tools to help get to carbon neutrality called the pH ribbon, which will start to look at different aspects of all the carbon, all the carbon that goes into that house and look towards the goal of carbon neutrality. So this is the area that I think is really important. And where we need to start off with. So we're going to pick our path. We're going to say, yes, we want to build a passive house, and yes, we want it to be net zero energy. So that's our path. That's our general overall guideline of what we want to build moving forward into the future. But how do we get there? And the first thing that I would say is you need to build your team. So if you as a homeowner or you as a developer have decided that you want to build passive, or even just build to the standard and not necessarily certified, you set your goals out. Now, how do we meet those goals? Well, we need to build a team, and we need to build a team that can get on board with what we're trying to achieve. So as you can see, everybody has a contribution here towards the project. So we have our design team that typically is going to primarily involve the architect up front. That architect is probably going to involve some teams behind them, like an engineer, HVAC design, electrical engineer, and maybe several other team members. We need those team members to understand what the goals of the project are and be aligned with that. And that architect needs to make sure that they're going to be willing to go through the paces to meet that passive house standard. The other aspect of this is the general contractor, right? So we have the four main components here, which is the architect, the general contractor, the owner's rep, and the consultant. Owner's rep / owner. If for a commercial building, you'd likely have an owner's rep. For a residential building, that would just be the owner. So all of these people need to come together and meet this and be in agreement with these goals. And then make sure that they're disseminating those goals and the way we're going to satisfy those goals back to their own team and communicate that. So the architect has their team. We have a consultant that's going to be working closely with the architect on their design to help them understand that their design is on the correct path to meet passive house. And then within passive house, because they want good checks and balances, you have a consultant that helps communicate what needs to happen to meet the passive house goals to the architect, the general contractor, and the owner. But then you have a certifier who is checking the design and checking the work of the consultant to make sure that it ultimately meets the standard. And those two cannot be the same. So if we hire a team to do consulting, we have to hire a different team to do certification. The general contractor has a lot on his plate because his responsibility is to take those plans that preliminarily achieve passive house and make sure that it actually gets implemented in the field. So that passive house, that general contractor should really be looking at the key subcontractors that he wants to be involved in that project to make sure that they're aware of the goals, ideally that they understand the goals, and if they don't fully understand the goals, that they're willing to learn and that they're a true collaborator in the process. There's all kinds of subcontractors that we want to pay attention to, but I think what we really want to focus in on here is we want to look at our foundation and our concrete contractor, because there's going to be things that we're going to be doing in foundation that are going to be different than they normally would. These days, it's pretty standard to put insulation underneath a slab and put it up the foundation walls, but we need to do it in a certain way to minimize those thermal bridges or to eliminate those thermal bridges. We need them to follow through on those basically bylaws that are created out of the passive house planning package. Rough carpentry, they're very important. Oftentimes that rough carpentry crew might install windows. That's a key component to passive house and making sure that it functions the way that it's supposed to. So we need to make sure that they're installed per the design, and we need to make sure that they're installed in an airtight manner. Sometimes we have separate window installers. The same goes for them. Ideally, what we want is we want that team to really be deeply involved. And what we find that helps tremendously from our point of view is we've always had, and most general contractors will have somebody that's responsible for QA/QC, quality assurance, a quality assurance person. Ideally, we would make that person the passive house implementer. So on top of his normal quality assurance items that he would review on any house that he was building, he's going to be looking at things like air tightness layers, making sure things are taped properly and installed properly, checking on those details that might be more difficult to address in terms of thermal bridging at our connection points from foundation to above grade construction and at the roof. All of those things need to become part of his habit of checking to make sure that the quality of those products are installed at the level that's expected. Another thing to be aware of here, and I think is really important, is sometimes it gets lost. owners are the most important part of this whole process. Typically, and passive house owners are driving to meet the goal of passive house or some sort of high performance building. They have certain goals that they want to see achieved from an aesthetic standpoint. And it's important that owners feel like they have agency and have true agency with the design team, the consultant, and the general contractor to make sure that they understand how things are coming together and that it's meeting their goals, not only from that aesthetic and performance standpoint, but of course there's budget considerations as well that need to be addressed. So once we have a path and we have a team, one of the things that we want to do, and some of this is, as I referenced before, is dictated by the path that we've chosen. We want to start looking at our methods and our materials. So how are we going to build this? Are we going to achieve this using a continuous insulation that we see up there, or a double stud wall, or maybe we're looking at off-site construction and some panelization? What other types of materials that we need to look for that are going to help us achieve the goals that we want to meet of thermal bridge free construction and air tightness, high performance windows? Oftentimes these materials are not as relevant, readily available or readily known. And so it's incumbent upon the team to be willing to do some research, to really look at what makes the most sense for the project for those high level items like budget, constructability, and some general knowledge or trainability on those products. So it's come a long ways over the last few years in terms of the available materials that are out there. But the thing that's, I think, is really nice about Passive House is you can take materials that are available, and as long as you're paying attention to the details and you're following through on the plan that's been devised, you can make them work. So I have some products up here that maybe some of them are a little bit more exotic, some of them are more readily available, but the point is that you can take materials that we've been using and methodologies that we've been using in construction for a while, and you can still apply them to the Passive House method and still meet that standard. This is really important. So, especially if we're looking to certify a project, and even if we're not looking to certify a project, but we want to build to the standard. The thing that's nice about Passive House is that you can actually measure your performance. And the thing that I like about certification is that it's a check on our homework as builders, and in particular, and to a lesser extent on the design. So we want to do, which is required anyways by code in most jurisdictions now, we want to do a blower door test. We want to make sure that we are hitting the performance requirements for Passive House. We want to be making sure that we are looking at all the details that are being executed in the field and make sure that they are being implemented per the design. But a great way to make sure that that happens is to include performance criteria in your contracts with your subcontractors. It's not an unusual thing, especially in the commercial world where you have performance contracts for time and for budget overages. It's not that big of a deal to add in some performance criteria. Now, where a contractor is probably going to push back is if he doesn't feel like he's been given the necessary tools in order to meet that criteria. So that's why it's so important to go back to the beginning have a clearly defined path of exactly what you want to do. Whether it's passive house certified, whether it's just building to the standard, whether you want to add something else onto it, have your team assembled and your architect with a plan that's been checked against some sort of criteria, which in this case is passive house. We have all those things in place. Then what we're telling the builder is the plan, if you build to the plan, you will be successful. So there's no reason why you couldn't put performance criteria in your contracts and have them be held to that. Like I said, follow your plan. This is going to be a theme in any passive house project. If we have a plan and it's a standard thing for or at least it should be a standard thing for all general contractors. If there's a dimension that says 5 feet, we have a dimension that's 5 feet in the field. If there's a standard that's written into the plans that says we need to have an air tightness level of X, then we should, as general contractors, meet that standard because it's on the plan. The important thing to understand and to remember is that you have a contract, yes, as a general contractor, but your plans are really your contract. Your plan, what you're saying is when you take that job on, is that you will execute this plan. The importance of having a good team that communicates and overlaps in communication between the consultant and the architect and the general contractor and the owners is just that. You get out in the field, the detail isn't clear. Please clarify, Mr. Architect. You get out into the field, it isn't working exactly how you thought. Let's get the other members of the team on board to make sure that we can either build to how it was drawn, or if it needs to be modified, get it modified and make sure that it still works within the context of passive house. Just follow the plan. The other thing is to train your team. So at Old Town, we have taken it upon ourselves to train several of our in-house team members, supervisors and project managers. And we've also trained a few of our subcontractors as well. Because we feel like it's important that they understand if we are building towards this standard, it's unfair for us to then go to our subcontractor and say, just throw it out on the table and say, we want you to build to this standard and not offer them an opportunity to be trained. Some training costs money. Some training can be achieved through the manufacturer of materials. They're more than happy to send trainers out, make sure that their product's being installed correctly. And in fact, I would even recommend that just because from a warranty standpoint, we want to make sure that it's meeting the manufacturer's requirements. But the bottom line is that you need to continually be training your team. And if you have a new product on a job, it is necessary that they understand that how that goes in. It also ties back to the more that you can standardize the things that you do as a general contractor and keep consistent materials from job to job, the easier it will be for your subcontractors because they're familiar with the material and you're not throwing new material at them from job to job. It's more consistent. That's why we do get pushback as a general contractor from our subcontractors, because they've been building it this way for 30 years. Now we're asking them to do it different. But if we do it consistent from job to job, it's not that big of a deal. There's a learning curve. They may push back on it a little bit, but if they understand that the difference between getting the job and not getting the job is then their willingness to be trained, then eventually it becomes just old habit, like the old ways of construction. Mentioned it before, QA/QC. When you're building a passive house, we have a lot of details on the page. Any house, whether it's a code built house or a passive house, has a lot of details. It is important that those details are followed from from a structural standpoint, from an aesthetic standpoint, and then when we're talking passive house, from a standards standpoint. Are we meeting the standards? Is that detail that was drawn out by that architect, is that matching up with what we see in the field? When you have several subcontractors out on site, it is difficult to expect quality assurance and quality control if you don't have some individual dedicated to that. A project manager or a supervisor is concerned about a number of things. They're concerned about the budget. They're concerned about getting subcontractors out on site on time, making sure that materials are there on time. They don't necessarily always have the time to look at quality control by stepping back and looking at it with a third eye. We've
got a question in
Yeah.
the audience.
Yeah.
In Zoom land. This individual is asking, how hard is it to design a passive house that is more intricate than a simple box often seen with the passive house?
So I would answer that simplicity of form is definitely a key part of passive house, but it doesn't necessarily mean that you can't have architectural interest. But it's also important to note, and what we're talking about here is form factor. It's important to note that form factor isn't just a contributor to making it easier to meet passive house standard. It's also one of the biggest reasons why we have increase in cost. The more complicated we have of a form factor, the more expensive that product's going to be for the same square footage for a house that has a simpler form factor. In terms of the design, you can do it and make it more complicated, but we want to keep as low of a form factor as we possibly can. And what I would say is, in terms of architectural interest, what we want to look at too is maybe things that are kind of added on to the outside of the house, as opposed to having something cantilever or an extra corner, something like that. We do want to keep our forms as simple as possible. So as far as QA, QC is concerned, what we find is important. We train our project managers, we train our supervisors. The expectation to them is to build to the highest quality, but we have an individual who is responsible to be out on site, checking in at key points in the project and on a weekly basis of general quality control and quality assurance, as well as the specific things related to passive house. And of course, what we see here in one of these photos is a blower door test. That is one of the key ways we know that we are meeting the passive house standard. We want to do a blower door test early and often, until we're assured, until we're confident that we've met that airtightness level and that it's going to hold for not just till the end of the project, but for years into the future. Commissioning is also another important part of passive house in general, but also in construction. I think especially in single family custom house world, and probably in the production house world, commissioning isn't always been the most important thing, but it is certainly necessary and required in passive house. And just in general, from a quality standpoint, and from an understanding that the systems that we put in place actually work, we want to commission them. And it just isn't heating and cooling equipment. It isn't just the plumbing fixtures. We want to look at all the systems that we have in the house, and we want to commission them. So for instance, like on air sealing, we're going to commission our airtight layer we're going to review it. We're going to make sure that everything's taped, that there aren't any breaches that have happened during construction, and we're going to and commission it, sign off on it. And then lastly is operational training. We're going to get through all of this and we're going to make this really fantastic house. We need to make sure that our owners understand how this house works, right? We need to make sure that not only do they know how to operate the equipment, but also what to expect from a house, a high performance house or a passive house. It's going to feel different. It's going to act different than the houses that we've typically been used to, up until, you know, high performance houses became a thing. So we want people to understand, like for instance, you might get condensation on your windows, but it's going to be on the outside of your windows. And that actually means that they're actually working correctly. We want to make sure that they have this piece of equipment in their house called an ERV. There's a filter there that needs to be changed regularly. We want to make sure that they're aware of all the equipment in the house, how that operates, how to maintain it, and then as well, how that house should feel and what it's going to be like for them moving into that house. And some of that is just walking them through the house at the end of the project and making sure that they become familiar with everything. So in closing, I'm just going to say this: details, details, details. From the very beginning, chart a clear path to building a house. It's oftentimes that I've met with clients and they don't have a clear understanding of what they really want from their house. They may understand what they like and the way that it looks. They may understand that they want 3 bedrooms and 2 bathrooms and 2,000 square feet, but they don't know how they want their house to feel. They don't fully understand how they want it to operate or how they want it to function. So from that, it's really dialing in those details to building your team that can help meet out those details, to material selection, to following the plans, and then to make sure that you are checking, double checking, triple checking all the way through the whole process. That is how we get to a successful project, whether it's passive house or not, but even, I would say even more so for passive house, because we're setting a standard and an expectation. We want to make sure that we are meeting those expectations. And with that, I'm happy to take any questions.
Sure. So I came in late, right as you're on selection of materials. It looks like a huge amount of research involved to figure that out. Has anybody done some work to try to organize those and rate them on the different abilities that you mentioned? Or
Yes, actually, the Passive House Institute.
mm-hmm.
So if you go to the Passive House Institute, there will be a whole host of materials that they have that they certify. So one of the things that institute does is it not only promotes passive house, but it also researches, tests materials, and then if it becomes a certified product, which any manufacturer can put their product up for certification. If it becomes a certified product, then particularly like windows and ERV equipment, that can become part of the passive house planning package, so that it becomes easier for the consultant, because it's within the software. They can select that, and the particulars performance data is already available. But more than anything else, you are correct. There is a lot of research, because sometimes we want to use the product and it isn't certified, And just because it's not certified doesn't mean it can't be used. But it may require some additional research as opposed to a product that's already been reviewed by the Passive House Institute.
Mark, could you stop screen share and activate your camera so the audience can see you speaking?
We can.
The passive houses typically end up without combustion.
Not necessarily. It depends. I would say that that's generally a goal. But there are passive houses that do have combustion. I would say that it's not. I would say that there's some challenges with that, and I would say that it's much easier to go in an all-electric application. But again, passive house is not. It's agnostic when it comes to.
I mean, I guess it depends on climate, for sure. If you're super cold climate, it gets tougher.
It does, but
place you need air conditioned, then a heat pump starts to make a lot of sense.
It does, but you know, there's heat pump availability. You know, that performs down to minus 25 degrees. So it's definitely it's definitely come a long ways. And there's a lot of different alternate heat sources that can be looked at, and you know, potentially combustion is one of those things.
What do you think of as kind of ballpark percentage cost increase over, you know, latest IBC, IRC code standards?
Well, I can point to a study that was done versus the California code, and that was depending on a number of factors. I've seen projected cost increases of 3 to 5% at max over California code. Code here, I would say it's probably about the same. And really what that comes down to is what we talked about, which is a good process. You can't just plop passive house on top of an existing set of plans and say that it's going to work. First of all, it probably won't work. And there'll be a lot of redesign, so there's cost there. But the more that you have your goals set for your project ahead of time, the easier it is to be efficient with designing and implementing these things, so that it's a more cost-effective proposition. I mean, there's no doubt that there's the potential. I mean, there's more insulation, right? So that's going to cost more.
Yeah.
But
higher end windows, triple pane.
Yeah, and triple pane windows these days doesn't necessarily mean that they cost more. I mean, I can cite a number of different double pane window manufacturers that cost more than some triple pane manufacturers. So in the last few years, that's become less of a concern.
That's good.
A question from the audience, the Zoom audience, virtual. They're quite real. They're just virtually, right? They're just somewhere else. Most contractors hire Spanish-speaking workers. Won't a typical building team need translation? And I'd like to elaborate on the question too. As for a second dimension or component. I work in the insurance industry, workers' comp in particular. And one thing I found from some of the general contractors is that especially with the building boom going on, they have less control over who they hire because they can always find another employer hiring agent somewhere down the road. For example, since I work in workers' comp, the concern is with safety.
Mm-hmm.
So if the hiring agent requires certain safety features and the crew doesn't want to use those, they just say, well, I'll just go somewhere else. So I guess it's two components. The first part being is there, a need for translation, and is this, sounds like it's highly specialized training, then also given a high demand for crews, gives you less control. I'm wondering what those sort of dynamics are for passive house and for, in your experience.
Sure, it's actually, it was actually a topic of conversation between a couple of my peers not that long ago, that there was a need to. One of the difficulties with passive house, and I think we're seeing different paths towards training now, is always been, for instance, initially a lot of architects were getting trained, and it wasn't necessarily contractors, but I will say that architects brought the general contractors in, and if they wanted the job, they were going to open themselves up to training. But it is filtering it down to the guy who's actually applying the tape or rolling out the membrane or installing the insulation in an appropriate manner is always the difficulty. Some of that's resolved with working with just like you would use the same materials from job to job, is trying to use the same crews from job to job, and I hear what you're saying, that that's not always possible, but the other part of it comes back to the passive house implementer or the QA/QC person that we have, in that if we have a crew that's a key crew that hasn't been trained before, we'll either try to ahead of time get them more intensive training like you would get through EMU passive program. If that's not possible, then we will bring out our manufacturer's rep. And most of the time, the materials that we're using, these manufacturers are pretty knowledgeable about passive house. Like one of the products that I had up there was from Rockwool for continuous insulation. They have a whole entire program around passive house, so they're very aware of it. The window manufacturers are very aware of it. I worked on a project from the Marshall Fire rebuilds where the windows that we used were manufactured in Lithuania, I believe. And they actually sent out a representative to train our installers on how to properly install those windows. It does create more of a burden on the general contractor to make sure that their subcontractors are on board with the details. But ultimately, if we're building a house and it's not a passive house, but we're introducing a new material or a new method, then we are responsible to make sure that that subcontractor is following the detail, is following the manufacturer guidelines, right? So this is a little bit more specialized, and I'm talking about more from the point of view of a single family custom home builder. So we take that time to make sure that that's correct, because there's a number of things that involve that: our reputation, the end quality of the end product, our relationship with our homeowner. Those things are important, that are enough to us that we get those things right. And I believe that that's the case for most general contractors. It's just that at the end of the day, we want to have somebody from each team who is dedicated to those passive house principles. So if we have an architect, maybe not everybody on that team is a passive house certified person, but there's somebody who's leading that team that's making sure that things are being built to that passive house standard or design. Same thing from the general contractor standpoint. So it is hard, and until high performance building in general becomes a more ubiquitous thing, we are gonna have that issue. Plus, we're also dealing these days with shortages in the labor and trade areas. And I mean, for us, one of the ways we resolve that, we're involved in some trade training groups up in northern Colorado. I mean, we just in general, we want to see more people in the trades that are doing that, have that, I guess, that pride of quality.
Question.
Yeah.
Are you able to utilize rebates offered by like cities or utilities? And like, do you have some examples, and do you see, are there things that aren't covered that you wish were covered, or rebates high enough, or what do you? We just talk about that space a little bit.
Yeah, so I'll talk a little bit specifically about like the Marshall Fire. So on the Marshall Fire rebuilds, Excel stepped up and offered different levels of rebates for different building standard programs. So I don't know if everybody's aware, but right after the fires, right before the fires, the city of Louisville and Superior soon after passed the 2021 codes with, I forget what the addendums were, but it required essentially to be all electric ready. It increased some of the it increased some of the standards around insulation, airtightness, etc. There's a big pushback because there was a perception, and it's actually, I mean, I will say it here, there was a lot of propaganda out there that would increase costs significantly to the point that people could rebuild. And the reality of it is that the reason that most people couldn't rebuild is because I think FEMA called it the most underinsured natural disaster ever. That there was just tremendous amount of people who were underinsured. So Excel stepped up at different levels from the 2021 code. They offered a certain level all the way up to $37,500 if you built a passive house standard. On top of that, we have the state electrification program. So if you're all electric, which passive house is definitely a preamble to that. You could definitely be all electric doing that. You know, I believe that incentive totals out around 10,000. Plus, Excel has some additional incentives related to certain equipment use. And I know that there are some other programs. We're working on a project right now where we're looking to take advantage of those for a larger development. And then for even our individuals. Now, you know, the problem with Excel rebates is you have to be within an Excel service area. So the state rebates tend to be more applicable to more people. But we can meet all those requirements. What I will say is they do not take the data that's generated out of the passive house planning package as a pathway towards getting that. You have to meet the programs that they set up, which tends to be HERS. So, which is not really HERS anymore. It's I forget what they call it now. But so we've played around with that a little bit. So technically, when you're building a passive house, you don't need a manual J or a manual D or a manual S, which are pretty standard things that most cities require in order to determine. If you're not familiar, manual J will kind of give you your heating loads of your house. Your manual D is duct design, and a manual S is equipment specification. So we've worked with different municipalities, and some of them have been fine. You don't need that. But then what we find is then we don't qualify for those rebates. So we end up doing them anyways. So it doesn't end up being the full amount of the money because you have to spend some money in order to get that money. And, you know, to do a HERS or, and to follow through with that, that could be, you know, a couple $1,000. So you have to take that off the top of the rebate that you're gonna get. Now, all electric, I believe you just have to turn in the data on your equipment, and then you qualify for that. So.
Question from the audience, from Zoom land. Aero barrier has been in use for several years now. It is claimed that if your air sealing doesn't meet your goals, you can use aero barrier to get there. What has been your experience with that in the field?
So I've been involved with a couple of projects that used aero barrier. I will say that especially when you're doing a retrofit on a house and you can't address air sealing to the level that you would normally be able to in new construction, it can be a good tool. But I would say that from my point of view, it's a last resort tool. In terms of practical use, I've not seen any data, or at least they haven't come forth with any data on the longevity of the product. For those of you who don't know what it is, it's basically an aerosolized acrylic caulk that is applied under pressure to the house, that as it looks to be pushed outside of the house, it will fill cracks, I think they say up to about 1/4 inch. I'm unsure of the longevity of that. Does that caulk eventually dry out? Does it start to crack over time? The other thing that we have found on a project that I was consulting on is that they come out and do a blower door. That's how they determine, right? So they start off with a baseline blower door, and then they start to blow their caulk in, and you can literally see the tightness increase while right before your eyes, because they're running that diagnostics of the blower test in real time. What we have found is that they hit their goal, and then you go and you do your other blower test, and it's not the same. It's worse. So what we recommend is that if you're going to use aero barrier, and I've been involved, like I said, I've been involved in projects that it was necessary to do so, that you reach beyond what your goal is. So if we're at a 0.6 ACH as required by Passive House, then we should shoot beyond probably double that to 0.3 or something along those lines, just to make sure that we're covered. Because the thing with that is, with aero barrier, is that once you are at a certain point, it becomes really difficult, because it wants to go everywhere. You want to do it at drywall and not when you have your finishes in, because then it becomes a nightmare to protect all of that. And I would say you probably can't protect all of that.
Something you said caught my imagination about feel, and I got a feeling for what you meant by feel, but you said the passive house is different, and that it has different expectations for the owner, different expectations for maintenance requirements, and that they behave differently essentially in the house. And can you elaborate more on that? I mean, I have for one time I walked into a house that had radiant heat in the floors, and it physically felt differently. I didn't know what was going on. I knew the house felt differently. I said, "What's going on with this house?" And the builder told me what was going on. I was like, "Wow, this is fantastic." But what do you mean by feel? If you could, is it like that kind of feeling, or is it more like your behavior is different, so you think about the house differently? You can elaborate on that.
Yeah, I would say that, I mean, certainly that's part of it, right? Like typically we wouldn't, I mean, not that you can't, but at least we don't necessarily put radiant heat in passive houses, because we've addressed through air tightness and good insulation the stratification issues that happen in a typical house. And that's where you really feel the difference with radiant in a more traditional house versus like forced air. But when you walk into a passive house without that radiant heat, it feels kind of the same way. It's very consistent air temperature from top to bottom and from side to side. The other thing is, I think the thing that you will notice, it is very, very quiet. You cannot hear anything outside. So, and primarily that's because of the windows. The triple pane windows are very, very good at reducing the noise that's coming through them. But also that also a side effect of the air tightness. If you think about it, we are reducing all the places where noise can get in because that's where air can come in, right? Just in terms of operation, similar to radiant heat, things tend to be more slow and consistent. So for instance, on your heat, I would not recommend to anybody that they run their heat up warmer when they get home, drop it cooler at night. Just set it at a temperature that you're comfortable with, let it sit, and let it operate on that level. It'll be way more efficient than trying to cut off your heat when you're not occupying the house versus when you are occupying the house. In general, that quietness is also to the inside, right? We're using heating and cooling equipment that if it is running air, like a mini split or air-to-air heat pump, or a geothermal system that's water to air, anything that's pushing air in the house is running at a much lower CFM, so you don't really hear it. You don't hear it. It's not a big blast of air that's coming out of ducts. It tends to run at a more steady rate, and it tends to be a lot quieter. Same with the ERV, running very, very low CFMs. So you're not really hearing any of that. So you not only do you not have the outside noise, but the inside noise it's incredibly quiet.
I had a question. So I come from more of like a product design background, so like interested in materials. What you said, like your team or folks have had to kind of do research to certify like newer materials. What materials have you seen kind of trending to like get this plan done essentially for like a passive house?
Well, I think it isn't so much about the new materials, it's about the materials that we're not using any longer, right? I would say for at least the last 20-25 years, spray foam has been a very big component to making something more energy efficient. And some people think airtight. And I would, first of all, your insulation layer can't be your airtight layer. They're two separate things. And even though that might contribute to airtightness, it is not your primary airtight layer, which is what a lot of people have used it for in the past. But we also know that it's very carbon heavy product. We know that it's a toxic product. I mean, it's literally a neurotoxin. I mean, you can't be in the room when it's sprayed. It definitely off gases, and there's other problems with it. So at least people who are looking to build passive, they are looking to limit products that are more carbon heavy.
Mm-hmm.
So we're seeing things like rock wool, which is better. It's still pretty high intense amount of energy to create it.
Mm-hmm.
Wood fiber insulation, hemp insulation, cellulose, which has been around for a long time, which is a recycled product. You know, when it comes to finished products, you know, it depends on the level of the person, but you know, people who like to build this way also look for other look for other environmental or energy I guess more friendly products. So So finishes, low VOC products. In the concrete world, and concrete's a big carbon contributor, we're looking for, you know, either concrete alternatives. A lot of people don't know, but you can live in the code, it's allowed to build a foundation out of wood. So it's not necessarily required to do concrete, or to look for other, instead of having a basement, put house up on stilts, basically with micro piles, eliminate a lot of the concrete that you would use to set your house up. There's a lot of different, products that you can look to. They're becoming more and more known, and this is why we also have conferences, right? We have the Passive House Conference. You're seeing more and more of these kinds of things bleed into even the International Builders Show in Las Vegas every year. I mean, they have a whole area where you can see these products. And I think just in general, the industry is trying to move that way, mostly because at a certain point, it's just gonna be necessary. I can tell you in Fort Collins, we have a 2030 carbon neutrality goal, right? That's 6 years from now. And it's a daunting task. And in fact, I know that at some point within the next year or two, they're going to introduce carbon rules when it comes to new construction. So it's becoming more and more of a factor for just even regular standard built code homes.
Question from the chat. Excel Energy has substantial subsidies for rebuilding with passive house design. Do you know how many projects have taken the offer?
The last time that I heard, there was somewhere roughly about 12 or 15. I don't know how many have followed through. I know one project that is getting close to being finished, called Sunflower Sanctuary, which is designed by Shape Architecture and is being built by Living Craft Homes in Louisville. There's there's 2 or 3 that EMU Building Sciences a part of, different builders, different designers. In Superior, there's at least 4 or 5 by one particular builder and designer group. So, you know, depending on who ends up following through, I know they had to declare their intentions with Excel at the beginning of their project. I would say, right now, we're probably on course to about 20 out of 1,000. But one of the things that I can say is that I have to check with Robbie Swartz. He's kind of involved with that aspect of things with the county. With the incentive programs and with the education that was done around the Marshall fires, I believe of those permits that have been pulled up to this point, we were close to over 50%, maybe even close to 60% of homes that were being built beyond the 2021 code, or 2021 or beyond, which wasn't a requirement. So they pulled back the 2021 requirement for the Marshall Fire rebuilds so that you could build in 2018. So at a minimum, we have 50 to 60% of people who decided to build better than the 2018 code. And to give you some just a comparison with, there were similar incentives developed for one of the fires in California, and they had less than 3% participation. So it's made a big difference. I give a lot of credit to like the Colorado Green Building Guild and groups like this who kind of created a good environment of education, and giving folks the opportunity to learn about the pathways that they might want to take. And I think a lot of builders and architects stepped up on that regard as well.
Another question from the chat. Is there a list of passive house experienced vendors, architects to builders, et cetera, to be able to tap for a new home build?
Yes, so, as long as they keep it up to date. So the Passive House Network, if you go to their website, they have in one of their drop-down menus, a list of people by region that are either certified tradespeople, which is typically what a builder would be, designer, which could be, which would more likely be an architect, and then a consultant who could be part of the process as well. Sometimes architects take that consulting piece on themselves, but I don't know that I would recommend that. I would recommend having a separate consultant, because there's a lot of pieces involved, and the architect has their own set of burdens that they already have to meet. So taking both of those things on can be challenging, but there are architects who do it. Other than that, because I would say that list is probably not fully comprehensive, I would say come to a Rocky Mountain Passive House meeting. You can even reach out to Passive House Rocky Mountain, and we can make recommendations. Because there are builders like the project that I mentioned, Sunflower Sanctuary. I'm not entirely sure that the owner, Frank, or any of his team members have had any specific training or would be on any register, but they're more than capable of building to the Passive House standard. And that's the thing about it, is that you don't necessarily have to have a certification in order to build, but you need to have kind of the will to do it. And just because you've taken the training doesn't mean you have the will to do it either. So it's really important from an owner's perspective that you vet that team really well and make sure that you're comfortable with either their level of knowledge or their willingness to learn, or both. But the first one that you do is hard, very hard from a builder's perspective. It gets way easier the second time you do it. So, but certainly, they reached out, we could point them and give recommendations.
And another question from the chat. Are there new imaging technologies to diagnose leaks in the building envelope? For example, portable LiDAR. This may be important for passive house remodels.
Yeah, I mean, LiDAR is, I don't know that I've ever seen it used in that capacity. What I typically see is doing a baseline blower door test in combination of using an infrared camera and making sure that you're doing that blower door test at a time where there's a fairly large delta between indoor and outdoor temperatures. So, also smoke tests, it's also important that when you're testing like that, you're not only depressurizing your house, but you're pressurizing the house. You do both, so that you can fill the house full of smoke, you can pressurize the house, you can start to see things leak out. If it's so leaky, you may not even be able to pinpoint it. So when you're dealing with a retrofit, it can get really daunting, and in terms of really trying to track down all those leaks. Now that is where aero barrier comes in, because it kind of, if you will, seeks out those areas. It just depends on the level of fastidiousness you have, I guess. At that, it's not, especially on retrofits, it's not an easy task, the air tightness. What I will say to that though, is it depends on, again, it depends on your goals and your level too, of commitment. Because it may just be easier to take it down to the studs than it would be to work with the existing building. But again, that's time and that's money. And really the goal here is to get houses better. So if we can't get it to the passive house standard in a retrofit. I mean, my house is a good example. I built with the methodology, or I retrofitted with the methodologies in mind, but I couldn't get to the airtightness level. And I wasn't willing to spend the money necessary in order to get to that airtightness level. And at a certain point, I was satisfied with where I was at. And it served me well. I was in the middle of the Marshall fires and I ended up, I had neighbors who lost their houses in the fire and I ended up, coming back to a house with no smoke in the house, no ash, because it was really airtight. And because I was all electric, they turned the electricity on within 2 days, and the gas was like another week and a half later. So I had heat and my ERV running within 2 days and was living in my house 2 days after the fire, when my neighbors couldn't even get back into their houses with heat for at least a week and a half. And then most of them had enough smoke damage and ash and soot in their house that I lived in my neighborhood by myself for like at least a month and a half, 2 months before people started to be able to come back. So, but again, it's about getting it better, right? Ultimately, yeah, it'd be great to have everything certified. But again, what are your goals from the beginning? And what are you willing to compromise on? And even if you set that goal to be passive house in your retrofit and you don't get there, it's not, I wouldn't call it a defeat. I would call it, your house is now probably in that 90 percentile of being better than any other house out there, even though it hasn't necessarily met the standard.
I guess taking a step back, like, what kind of energy savings does a passive house realize versus whatever your average house is? And maybe, I don't know if you tracked yourself. I mean, I know you said you didn't build it quite to standard, but did you take a look at your energy bill and how it changed over time?
Yeah, well, first of all, as codes are advancing, that delta between energy savings is starting to shrink a little bit. But generally, we would say about 85% over a code built house, in that range. My experience is my house, once I got rid of my gas furnace and I went all electric, I would say my energy bills were about the same, but I was also charging a car. So I wasn't charging a car before, and I had a gas furnace. I swapped all that out. I started charging the car. It was about the same. Then about a little bit over a year ago, put solar on. I'm net positive. Like I mean, because of the way Excel does it now, I have probably like I don't know, $5,000 Excel right now that I can't access, and they don't give me. That one day I guess I'll use it. But.
We should wrap up where it's a little past 8:30. Thank you everyone for attending. Those of you out in Zoom land, as well as those of you who are attending in person. Don't forget, next month we are having SEE Holdings talking about the hydrogen powered train. We look forward to seeing you guys next month, and have a good month in the meantime.